Have you ever wondered how SpaceX, NASA, and other space companies leave a 1.7 pound of thrust with 3,400 degrees Celsius temperature of the rocket off? I'm sure all of you must think there must be some secrets or miraculous thing happen there. This rocket technology is a great modern engineering technology that has been made by humans since 1926, which involved over 1,000 engineers with over 500 fields of study. For example, in order for a rocket to be successfully launched, the design criteria, material selection, and other analysis simulation must be made, especially the crucial part of the rocket motor, which is rocket engine. The study of the rocket motor is very important as this part of rocket is where the combustion process undergo. There are three types of rocket motor, which are liquid, solid, and hybrid rocket motor. In my research, I'll be covering on the solid rocket motor, as this type of rocket motor is the easiest and used widely in the most of rocket application, including missiles, map tracking, and even space exploration mission. Rocket motor consists of propellant grain, liner, insulator, motor casing, and rocket nozzle. The most crucial part in the rocket motor is the liner and insulator, as the selection of the material is very important here because the propellant burn radially from the direction of the propellant grain. It will produce a high temperature and pressure. The insulator inside the rocket casing must have a good thermal insulation properties in order to protect the outside casing of the rocket motor from the high temperature and pressure. In this video, I will be sharing to you my study on the simulating on the heat transfer performance of ablative insulators of composite solid rocket motor using Abaqus software. My objective in my study is to analyze the temperature drop along the insulator materials of fiberglass, paper, and carbon fiber during the propellant combustion process. The second one, to determine what is the best materials to be used as insulator for the composite solid propellant motor. In this research, I use Abaqus software with the analysis type of heat transfer, starting from the modeling the part. Second one, input the material property, meshing, initialize, and post-processing, and finally visualization and plot. For the result, the initial temperature set, which is the average combustion temperature inside the rocket motor, is 600 degrees Celsius. As a result, we can see from this figure, all the propellant grain insulators have been simulated and visualization has been made with representing the temperature contour. We can observe that the outer surface layer represented by the blue color of the fiberglass material shows a temperature of 33.7 degrees Celsius, which the paper shows the temperature of 40.1 degrees. Carbon material resulting the outer surface layer temperature of 247.6 degrees Celsius. This fiberglass shows the least outer surface layer temperature, followed by the paper and carbon fiber. This value of the surface layer temperature indicate that the final temperature result from the first layer, so the least the temperature value at this outer surface layer of the insulator, the more the material convect the heat. From the curve of all plot there, we can see that all of the curve shows the same trend, which is the more distant along the path, the less the temperature. The distance along the path is the distance of the insulator outer layer surface to the propellant liner grain. Tabulated data shows that fiberglass material show the temperature drop of 546.7 degrees, while the paper and fiberglass observe the temperature drop of 535.486 degrees and 185.61 degrees Celsius respectively. Fiberglass observed that the highest value of temperature drop from the first layer onto the outer layer of the insulation, followed by the paper and carbon fiber. This can be proved that fiberglass is the best material to be used as insulation material in the solid rocket motor compared to paper and carbon fiber.